Hello everyone, my name is Divyemohan Aggarwal and I am from Electronics and Computer Engineering branch. My roll number is 10199506. Thank you.
Warm greetings. My name is Shobhit Sinha. My roll number is 1018150004, ENC1, and my capstone group number is 1, CPG1.
So hi everyone, myself Reetpal. I'm from Electronics and Computer Engineering and my roll number is 1011505. So thank you.
My name is Saksham Sharma. I am from Electronics and Computer Science branch. Roll number 1018150060.
Greetings, my name is Priyam Gupta. My roll number is 101995008 and my branch is ENC1. I'm from Capstone Group, CPG1.
Greetings teacher, my name is Priyam Gupta and today I'm going to present our capstone project on land use classification using ML and AI. Our project wants to make a state-of-the-art image classification system that is user-friendly and can classify satellite images into their particular categories like river, highway, forest, etc. so their distributions can be studied. Now, current implementation only focuses on RGB band, well, because it makes the project much more user-friendly, so it can be used with commonplace satellite apps. Next, this is the main pipeline of our project. In this pipeline, as you can see, client uploads an image which takes it into ML model, which classifies the image and returns the image as output, which can be seen in the result page. So how does our machine learning model actually works? It basically includes three basic steps, which are explained further. First step was to build a cloud classifier. Now, cloud classifier, what it does is like satellite images have a lot of cloud to separate cloud between in the images as they're taken from the sky. So to separate that cloud from the images and to discard those images, we made a cloud classifier. We collected a lot of data from pre-built and self-made data sets, as you can see, and we augmented the data that we got from a self-made data set so we can make it bigger and using various sophisticated augmentation techniques. Now, this is the accuracy of the cloud classifier model that we trained. As you can see, we ended up going with the ResNet 50 since had the highest accuracy of all the three models that we tested. These are some classification results. Now, the second part was segmentation. This part was before training our model into a land use classifier. In this step, image is passed through a model which was created in the previous step so that it can detect whether this image has cloud or not, and the images with clouds can be discarded so that our final land use classifier dataset that we train on is perfect. So these are the different categories that our model is built to identify, and it is based on the Sentinel-2 mission nomenclature, which is a widely used nomenclature in land use classification. And I think keeping this our project in the same nomenclature will give it more usability and viability. Here are also some pre-built in this one also we use, as you can see, Sentinel-2 dataset, but apart from that we also created our own dataset using ISRO images, which was again then augmented to create a more sophisticated dataset. These are the accuracies of various different models that we tested on our classifier and the results of their accuracy. So as you can see, we ended up going with the model 8, which is an ensemble of model 6 and model 7. As you can see, this is the confusion matrix and some misclassifications were happening in the earlier. So how do we deal with that? We made an automatic data cleanup which automatically cleaned up all the misclassification. Then we retrained the model so our model was perfect and could classify image perfectly. And this model now has been integrated with our website, whose demo Divya will give to you now. Thank you.
Okay, so I hope my website is visible. So this is our capstone website, and as you know, our topic is land use classification using ML and AI. Here we are using HTML, CSS along with some Bootstrap. In the backend, we are using Flask for our model and to handle the image uploads. Also, we have provided an interactive map here to the user, so he can screenshot images from here and directly upload them and see how our model classifies the image, right? What are all the classifications of the image, right? So in the backend we have arranged a method using app.config which automatically reduces the image resolution to 64 by 64 since our model is trained to handle images of 64 cross 64 size, right? So no matter how big the size of the image, it will be limited to 64 cross 64 using max app.config in the backend in Flask, right? Along with that, here we have given a brief introduction about our project, summary about this project. What is it about LU and LC, land use and land cover, right? So now let's upload a file or image. Let's select this image and upload it. Okay, now let's click on upload. Okay, so the prediction result shows us that this is the image that we have uploaded, and the result is that the uploaded image is a river. Now let's see what is the prediction table, right? So the prediction table shows us the classes on which our model is trained, the various classes, along with the probabilities, right, of in each class in this image, right? So annual crop is 0.813 or 81.3%, right? As you can see, here are a lot of fields, right? Herb vegetation is 0.119, highway is 0.220. As you can see, we can hardly see any roads in this image. Similarly, there are industrial, pasture, permanent crop, residential, river, and sea lake. Now, out of all these, river has the highest probability, and so it has been highlighted in bold letters, 0.94 or 94%. Hence, our result is that the uploaded image is of a river. So this is the website that we created for our land use classification model. Thank you, everyone.